V model. Okay, in the picture you can see it's looks like a V. One is developer life cycle, one is tester life cycle. And developer life cycle we say it's a verification phase, and then tester life cycle we say it's a validation phase. So both work together, like simultaneously they work together, and then they develop the, like they use this model to develop the software. So V-shape model verification and validation model is an extension of the waterfall model, but with an emphasis on validation and verification at each development stage. Each phase has a corresponding testing phase, and the process is structured so that testing and validation occur simultaneously with development. So this is an extension of the waterfall model, and but it has verification and validation phase, and they work simultaneously. The one is developer side and one is tester side. So whatever the developers will do, like make the things design or code, so tester will check them. So any changes required, they will send it to back, and then developer also work on those changings, and then they move to the next phase. Okay. So what are the verification and validation? Verification, like in simple words, we say that verification is the process in which we will check that the options, for example, are the task which we have stated, it is working fine or not. Like if we take an example, so for example, if we take an example of login button, like I am using this example again and again, like this is the simple one. If we are having a login button in an application, okay, so here what is the verification? We have pressed the login button, and yes, we are login. So this is verification, like this is working fine. Then validation means like for the what are the stated purpose for which we have made the login button, is it doing that purpose or not? So yes, if it's our application is login, so definitely we have validated that yes, the validation is fine for this login button. So in simple words, these are the verification and validation. Okay, so let's see verification. It involves a static analysis method review done without executing code. It is the process of evaluation of the product development process to find whether specified requirement meet. Okay, so here as an in example, we have seen that if we press the login button, is it login to the app or not? So if it's login, so definitely it's meeting its requirement. So then we have validation. It involves dynamic analysis method. Functional, non-functional testing is done by executing code. Validation is the process to classify the software after the completion of the development process to determine whether the software meets the customer expectations and requirements. So here, if we have login, okay, and we press the login button, and we are logging to the home screen, for example. So yes, if the button is working fine, so definitely we have validated that like it's meeting the customer expectations. So V model contains verification phases on one side of the validation phase on the other side, and the verification and validation process is joined by coding phase in V shape, thus it is known as V model. Okay. Then we have different phases of verification phase of V model, and different phases of validation phases of V model. So who will read this slide? Thank you.
Business requirement analysis. This is the first step where the product requirements understood from the customer side. The phase contains detailed communication to understand the customer's expectations and exact requirements.
Okay, so business requirement analysis means this is first step, and in which we understand the product requirements and from customer sides. Okay, so whatever the product requirements are, project requirements are, we understand it from the customer side, like whatever the requirements asked by the customer, they should be included in the uh, product. So we understand them, and it contain a detailed communication so that we can understand the customer expectation. So sometimes when we ask customers about their requirements, they are blank, they don't know, they just say that okay, I have a I am going to launch a clothing brand. I just need a website. They don't know like which type of color scheme they need, which type of background need, which type of categories they need. So then this is the now this here is the person who is gathering the requirements from the customer. They are on the front end, like they have to ask different questions from the users or customers so that they can get their requirements. Like they can give different options to customers, and then customer can choose from those options, and then they can give their requirements. So next one.
System design. In this stage, system engineers analyze and interrupt the business of this proposed system by studying the user's requirement document.
Okay, so in system design, the system engineers are analyze and interpret the business of the proposed systems, and then they go through the requirements which are given by the users, and then they can implement those, like they can work on those requirements for designing the system. Next one.
Architect design. The baseline in the selecting of architect is that it should understand all which typical consists of the list of modules, brief functionally of each module. These relationship dependencies, their database tables, architects design technology details, etc. These integrations testing models is carried out in the particular phase.
So in the architecture design, this is the baseline in selecting the architecture. Okay, and in which all the modules, it consists of different list of modules, and for the functionality for each module. So like whatever the modules we have to design in the system, it includes the description of that module and the functionality of that module and their interface relationships, like how they will interact with different other modules, how they are dependent with the different modules, how database tables are created, by which options will be available in the database, like how which type of data we will store in this table. Then architectural diagrams, okay, through like maybe you have seen use case diagrams or activity diagram, process diagram, data flow diagram. So these type of diagrams are made in this stage. And technology detail, like what languages or what software we will use to develop the system. The integration testing model is carried out in a particular phase. Okay, so next we have the module design. Okay, in the module design phase, the system break down into small modules. The more detailed design of the module is specified, which is known as low level design. So in the module design, we will design each module separately, and we design each module in detail so that we can specify their requirements, so we can understand like how these module link together, and all these things are come in module design. Then we have coding phase. After designing the coding phase is started. Based on the requirements, a suitable programming languages decided. There are some guidelines and standards of R coding. Before checking in the repository, the final build is optimized for better performance, and the code goes through many code reviews to check the performance. So in the coding phase, we decide the language, which language is suitable for designing this type of system. Then we code each module one by one, and we you can say make it you can say to work better, and its work we will work on its performance so that it can uh, respond to the users quickly. Okay, so these type of requirements we will implement in the coding phase. Then we have phases of validation phase. The previous one are phases of verification phase. Now we have phases of validation phase. So in this we will do different types of testing. There are 4 types of testing phases: unit testing, integration testing, system testing, and acceptance testing. So unit testing means this is the simplest method of testing, in which we take a single unit and we test it. So like for example, if we take an example of again login button, so this is the simplest unit of any application or any website. Okay, so we will take this unit as a for testing, and we will check if we press the login button, either we are going to login or not, so we go to the home page or not. So this is the simplest you can say definition of unit testing. Then integration testing. Integration testing means that we combine 2-3 components, and then we will test them, either if we you can say press one button in first screen, is it moving to the next screen or not. So for example, if we take an example of here, you can say WhatsApp. Okay, so you are using WhatsApp. Now you have different options on the WhatsApp. So you have chat option, you have calls option, you have update option. Okay, so now for example, we have combined all these options. So once we press the call button, now they are at the home screen. But once we press the call button, we go to the call screen. Once we press the updates button, we can go to the status and updates screen, where we have seen like who has put it the status, from where from which channel we have updates. So this is how they are combined and integrated together. So in the integrated testing, we will check that if they are connected together, either they are working fine or not. Then in the system testing, we will fully test the whole system, and in the acceptance testing, we will test either the application or software project, or whatever the project is made for, is it meeting the requirements of the users or not. So this is how acceptance testing works. Okay, so in simple words, we have seen the what are these types of testing. So let's see, we will one by one check what is mentioned in the slides. Okay, so first one is unit testing. In the V model, unit test planes are developed during the module design phase. Here they are saying that in the design phase, we will develop the unit test planes. These UTPS are executed to eliminate errors at code level or unit level. So these are used to eliminate errors. And a unit is the smallest entity which can independently exist. For example, a program module. Okay, this is the smallest independently existing entity, and unit testing verifies that the smallest entity can function correctly when isolated from the rest of the course units. So once we test this smallest entity for its functionality, so it is we check that if other codes or units are not integrated with it, so isolated like alone, it can work or not. So this is how unit testing works. Then integration testing. Integration test planes are developed during the architectural design phase. These tests verify that groups created and tested independently can coexist and communicate among themselves. Okay, so integration testing includes more than 2 entities, or you can say groups of modules which can interact together, and then we can test them, either they are working fine or communicating with each other or not. Then we have system testing. System test planes are developed during system design phase. Unlike unit and integration test planes, system test planes are composed by the client's business team. Okay, so whatever the client is, their side users can compose these tests. Like the client side people can do this testing. They can check different options, different modules, different design. You can say design of the software. Okay, so colors, I think color schemes like this, these type of things they check from the client side, and then they can provide you feedback. System test ensures that expectations from an application developers are met. Okay, then we have acceptance testing. Acceptance testing is related to the business requirements analyst part. Okay, and it includes testing the software product in user atmosphere. So user atmosphere means on user device or client device. We have to test these software. Acceptance test reveal the compatibility problems with the different systems which is available within the user atmosphere. So it revealed the compatibility problems. Okay, if the system, for example, the developer who is developing the application or developing the software project, okay, desktop, any desktop application. Now developer device is having 4 GB RAM or 16 GB RAM and 464 hard disk. Okay, but and the developer is developing the application according to his own device size or platform. Okay, like he has designed the software in such a way like it's requiring for you can say 8 GB RAM and 464 for example hard disk. But now the client is having the device or having the PC or laptop, whatever the device is there, which is having 4 GB RAM and 256 GB hard disks. Now, once client will try to install that software product in their PC, okay, so definitely that software will not run on the client side because developer made it like they have mentioned that they have made the software in such a way like it will work only for the systems who are having the 8 GB RAM initial or higher than 8 GB, or the hard disk they require like 464 or higher. Less than 8 GB RAM, less than 464 GB hard disk, this system is not working. So definitely once we are designing, it will create, so it will create a compatibility issue when we are going to test the application or test the desktop application in the client atmosphere. So we have to consider these types of technical requirements when we are gathering the requirements from the clients and also when we are developing the requirements. So we have to keep in our mind that what type of system the client is having, and we have to make the applications or softwares according to those requirements so that it will not create any type of these type of compatibility issues. So this is how acceptance testing is done. And here you can see also they have mentioned it conjointly discovers the non-functional problems like load and performance defects within the real user atmosphere. So maybe if definitely if the client is having 4 GB RAM or and the system is made for 8 GB RAM, definitely it will load like it will take time unloading. Okay, and it will give you poor performance. So maybe for example, if I can give you here an example, I have given like I am giving classes to level 3 computing. Okay, and I am giving them classes on mobile application development course. So that course requiring a Android Studio. So once we check the software like Android Studio requirements, they mentioned that 8 GB RAM is requiring for installing this software. If you have less than 8 GB RAM, then it will it will give you errors, like you will have load problems, it will respond you late. So I have experienced it. because before I was having 4 GB RAM and I have installed that software, and it's whenever I click any option, it takes a lot of time and stucking again and again. So later I have increased RAM, and then now it's working fine. So this is how acceptance testing work. Okay, so now we have pros and cons. So first of all, we have early testing. Early testing means testing start as soon as module is developed, reducing the chances of late stage bugs. Okay, once one module is developed, we test it, and then we can avoid the chances of late stage bugs. Then clear mapping. There is a clear and direct relationship between each development phase and its corresponding testing phase. Okay, so that is why we can have this benefit of V-shape model. Improved quality with the verification and validation integrated at each step. Quality assurances better integrated into the process, leading to fewer defects. Then we have cons. Rigidity. Like waterfall, the V-shape model issue assumes that all requirements are understood upfront, making it less flexible when changes are required. So in the first stages, if we gather all the requirements and we define all the things, so maybe in the later stages we may need any changes. So it is also rigid like waterfall model. Then limited customer feedback. The model does not facilitate regular feedback loops with stakeholders, which can lead to misalignment between the development process and user expectation. So here feedback mechanism is not available, and we cannot gather feedback on each module development. So once the full product is you can say designed and developed and we deployed it, so maybe users require that this is not required, or they are having these type of requirement, so it may make you can say issues for us. Then difficult to manage large projects. For complex or large projects, managing numerous parallel testing activities can become challenging. Then what are the applications of this V-shape model? The V-shape model is suitable for projects with well-defined requirements where equally assurance is critical, such as medical or aerospace industries where strict regulations go on the development processes. So these are some of the examples where we can implement V-shape model. Okay, then what are the few differences between waterfall and spiral model? So in the waterfall model, the developers gather and determine project requirements once at the beginning of the process and build their project task on these determination. Okay, so in the first stage, the developers can gather the requirements and understand the requirements, and then they start building the project. In the spiral model, the developers gather requirements at the start of each iteration. So in the waterfall model, for whole project, we gather the requirements from the stakeholders, and in the spiral model, we gather requirements at each iteration. The waterfall model is best for small projects in which the goals are clear, while the spiral model is better for larger projects of greater complexity. Then waterfall model can identify risk only toward the end of development during the testing stage, and spiral model integrates risk identification and testing in each iteration. So as we have seen in the waterfall, we have to go step by step. So testing stage is at like you can say the last stage in which we can test, and then we can identify any risks or any issues are coming, and in spiral model we can identify the risks or potential issues in each iteration. Okay, so this is for today. Okay, do you have any question till now?
No, ma'am.
Okay, so there are few questions. Okay, in your opinion, which life cycle is most convenient one? So any one of you, what are your thoughts about these models? What do you think? Which one is most suitable? Waterfall, V-shape, or spiral?
Oh, waterfall?
Maybe or maybe not. Okay, so waterfall is like if you have a well-defined requirements at the earlier stage, then it is best for you.
Spiral
Like,
model.
huh?
Spiral model.
Yes, that one is also good. Like, it's an iterative model and it is more, you can say, uh, convenient. Like, you can do the iteration and you can make the changes in earlier stages and you can implement the changing needs of the business.
Yeah.
Then, how do you think about the waterfall model? So, I think so, Zabin answer is for this question is correct. Okay. So, do you have any question?